Hello, and welcome to today's Hangout, HILTI Button for Firestop, making BIM Firestop easier than ever. This Hangout is brought to you by Applied Software's Construction Technology Group, the premier construction systems integrator in North America. I'm Elisa Bowman and delighted to be your moderator today. Throughout our presentation, we encourage you to interact with us by typing in questions and comments using the questions pane. We will be answering questions at the end of the presentation. Please take a moment to introduce yourself in the chat pane. We want to know who you are, where you're located, and anything interesting that you would like to share with us. This Hangout is being recorded and will be available to you online on our YouTube channel. We will also send you an email following the webinar with a link to the recording. If you haven't already, search Applied Software on Facebook and like our page to receive the latest information and special offers. When you visit our website at www.asti.com, there is a complete schedule of upcoming events, webinars, trainings, and more. For HILTI, we are having 3 upcoming webinars on Thursday the 25th, Wednesday September 28th, and Wednesday, October 26th. These will each be at 12:30 to 1:30 Eastern Standard Time. At the conclusion of this Hangout, a survey will pop up. Complete the survey to be entered to win a $25 Amazon gift card giveaway. You must complete the survey to be entered into the drawing. Our presenter today is Robbie Sadawi, a Senior AEC Solutions Specialist with Applied Software. Robbie received both his bachelor's and master's in architecture with more than 25 years experience. He is often invited to speak at AU, RTC, and AIA, and is a published author. His Autodesk certifications include Building Specialist in Technical Sales and a Revit Implementation Expert. He uses a consultative methodology, and he also has a structural specialization. Welcome, Robbie.
Hey, thank you, Alyssa. Okay, so today's presentation is about the HILTI button for Firestop and how it works with Autodesk applications. So with the HILTI button for Firestop, AEC professionals can populate building information models with appropriate Firestop components easier than ever through automated clash detection and product selection. The HILTI button for Firestop is an add-in for several Autodesk applications such as Revit, AutoCAD MEP, CADmep, and Navisworks Manage. Also, the HILTI button for Firestop automates the entire Firestop BIM process by identifying and qualifying penetrations, as well as recommending UL-listed Firestop systems, saving you time and giving you the documentation required by Firestop building officials, such as fire marshals. So some of you may be familiar with HILTI as a corporation which is located in Europe, just south of Germany, between Austria and Switzerland. And their headquarters in the United States is in Plano, Texas. But HILTI is famous for their, their power tools, the drills, and other hardware that they make. But they also make Firestop products, such as the ones you see on the bottom right. The cast-in device, which is placed on floors, the wall device, and the collars, and the block, the Firestop block. So we'll be talking about those. So what is Firestop protection, or what is fire protection? There are 3 strategies for fire protection as known to different building codes and AEC professionals. The 3 primary strategies used to save lives and mitigate damages when a fire occurs are containment, suppression, and detection. With containment, you restrict the movement of smoke and toxic gases and helps contain the smoke in the room of origin. Suppression, such as using sprinklers, help extinguish fires until the first responders arrive. Detection is smoke detection devices such as fire alarms and emitting an audible or visual signal to alert the occupants that there is a fire hazard. So we can't rely on any single action or safeguard to keep people safe. So it's important to have multiple levels of safety. So why is containment better than other solutions? There's 5 reasons for that. Firestop is required by building fire codes. It must be included in the design documents and specifications. It's enforced by the authorities having jurisdiction. Most field problems can be avoided by proactively including Firestop systems in the design process, and it is a preemptive way to save lives, assets, time, and money. So since Firestop saves lives and assets, it's a key component in the building value chain. So what is the current activity for Firestop versus what the kind of implications that you get out of that? So currently what AEC professionals do, they improvise field discussions. They use casting devices at best. Inaccurate estimation process happens as a result and requires a manufacturer representative for product selection available in the field. So the implications for that are spending too much time on details, modeling, or selecting products and approvals. It's a tedious process, of course. The decision making in the field is a time-consuming process, and inaccurate bid results in change orders, inaccurate purchase orders, and high possibility of rework required by a fire marshal. So by including Firestop in the design phase, the decisions can be made in advance, and thus you save time and money. So let's focus a little bit more on the HILTI solution, the button for Firestop. How can it help? You're getting accurate BIM model takeoffs by placing those components inside your BIM model. Automated product selection and approval, accurate bids, purchase orders with bill of materials, BOM, automatic submittals, and start early to avoid errors and omissions. So all of these factors, they help include the Firestop solution in the design phase, and decisions can be made in advance and saves time and money. So from an application standpoint, what is the 5-step process to start in the BIM authoring tool and then do the round trip to Navisworks and come back to the BIM authoring tool again? Step 1 is identifying and qualifying penetrations. Step 2 is exporting to Navisworks, manage. Step 3 is to perform the clash detection required to identify where the penetrations are. Step 4 is to define UL systems and products using the HILTI Firestop Manager. And step 5, which is the last step, is to populate the 3D models with the Firestop BIM components. At the end of the presentation, we'll be taking your questions, so please don't hesitate to send your questions over to Alyssa. She's waiting for that. So at a glance, you are working here with 4 applications. Of course, Autodesk Fab MEP, Autodesk AutoCAD MEP, Autodesk Navisworks Manage, and Autodesk Revit. And they all have a full integration into this HILTI add-in for Firestop. So what does it look like inside of the Revit application? When you install the application, it shows up in your menu, just like an add-in. It has these 5 buttons. The first button on the far left allows you to qualify floor elements typically in structural models. Then you can qualify wall elements, typically in architectural models and structural. Then qualify MEP elements such as ducts and pipes. Then when you're ready, you can start the Firestop Manager. And the last one is to auto-populate the HILTI Firestop products into the Revit model. So what does the add-in look like in the AutoCAD platform, AutoCAD MEP and Fab MEP? First, it's very similar. You qualify the Fab components, qualify the MEP components, starts the Firestop Manager and populates the components into the model. So it's a very similar process. So this would be step number one, which is identifying the penetrations and qualifying them for use in the Firestop Manager. So we're looking at walls, slabs, or MEP components. And we are modifying their fire rating, their barrier type, penetrating type, material, and insulation. In Navisworks Manage, you can perform 3 tasks. First, find the Firestop clashes, start the Firestop Manager, and assign the different HILTI components for Firestop to the different penetrations. And you can toggle on the Firestop status on or off. Later on in this presentation, we will be doing a live demonstration, so please stand by for that. So again, the process in Navisworks starts with calculating the Firestop clashes. That will take a few seconds, and then it will list the clashes as you are used to here using the clash detection of Navisworks Manage. You can browse through them one by one, and you can see here that around this duct penetration, Navisworks will locate that penetration and highlight it with a certain color. The toggle will allow you to toggle the status of the penetration. When you first run the clash, the status would be under clarification. You haven't made a decision yet. When you assign a UL approved system to that penetration, then that penetration color turns green, and if you need more investigation, then it will be assigned an EJ status, which stands for engineering judgment, and that will be the yellow color. The next step is to transfer the clashes to the Firestop Manager in Navisworks Manage. You see all the clashes listed here, and then we populate those automatically. And of course, the last step is to basically review the assigned clashes and make sure that they match with your expectations, and you have the ability to change them if you wanted to, based on your past experience with Firestop products. So again, in Navisworks, the main menu in the Firestop Manager contains 5 buttons. The Assign button, number 1. Number 2 is the Unassigned button, which reverses the assignment, of course. Number 3 is the Match button, which after changing the one penetration, you are able to match similar penetrations. That's number 3. Number 4 is the BOM button, or the Bill of Materials, which allows you to generate a bill of materials in Microsoft Excel file format. Number 5 is a submittal, which you will need to submit to the building official or the fire marshal, which contains all the cut sheets and product information that you need to pass inspection. Now, this is a round trip, which makes the whole thing so beautiful. You bring it back from Navisworks into Revit or AutoCAD MEP or Fab MEP, and then you'll be able to populate the model automatically. Wherever there is a clash, that will be the location where that device will be located, such as those devices you see over here. So you have different types of devices. There are wall devices, there's floor devices, and some other devices as well. All right, let's move on now to the live demonstration. I'm going to switch now to Revit. We have here a hospital building, pretty large building that contains the structural, the architectural, the MEP, HVAC, plumbing, electrical, fire protection, all the disciplines involved. As you can see here, we are now in the HVAC model. I'm going to switch now to a plan view, and then simply create a perspective view so we can do a walkthrough just to see what this building looks like. Now this is a large model, so just be patient. It may take a few seconds to regenerate. All right, so here's the model. I'm going to turn on my shading view, and I'll go ahead and start using my navigation toolbar to start navigating through the model. And as you can imagine, it's very bumpy, it's very slow because you're looking at it inside of the BIM authoring tool. So if you're trying to find penetrations manually, good luck with that. It's going to take some time. There is probably thousands and thousands of penetrations between structural, MEP, and architectural components. So there must be a better way to do it. So I'm going to let the software do that. I'm going to close that view and then switch back to the 3D view. So in the 3D view, I'm simply going to isolate specific views such as ducts or pipes, specific Revit categories such as ducts in this case. Okay, and then we'll zoom in on these. And if we make a big crossing window around this, you will see that in the selection filter of Revit, we have ducts and model groups. So what I'm going to do is I'm going to select ducts only, and I'm going to isolate this category. And then apply this to the view. That's how we prepare the model for qualification. The next step would be to simply select all the ducts in the view and then activate the HILTI Firestop qualifying MEP elements. This will retrieve all the properties, instance properties and type properties of these ducts, and it will open up in this Firestop Manager. Next step would be to group similar ducts and locate their penetrating type. In this case, it's sheet metal duct. Then the material, in this case, is a spiral wound HVAC. And if there's any insulation, we can also assign that as well. And we can go ahead and assign that to all sort by type, and then we can simply click on the header of that column, and then select all of the ducts that are in question, and simply go ahead and apply that to these elements. We happen to have about 4,200 elements or ducts in this view. This will write a database file that will allow Navisworks to identify the fire rating and the material and the installation for each of those components. The next step would be to export this to Navisworks. We can use the add-in for Revit to export this to Navisworks, or we can simply use the export function and export an NWC file to Navisworks. Now, in the Navisworks settings, you may let me mention this. You may want to check your Navisworks settings before you send this out. Make sure that you have the proper project coordinates. In this case, it's project internal, not shared. That you have the minimum possible amount of information here, such as convert element ID, convert element parameters, convert element properties, and the rest of the export current view, and the rest of the buttons are not checked. You do not want to export room geometry, for example. Once you get those settings down, you can go ahead and write this. I'm going to replace the one that I have written before. So this process is repeated over and over again for the architectural, the structural, the plumbing, fire protection, and electrical models. Obviously, we don't have that kind of time today to go over every single one of those models. So I'm going to fast forward and show you just sample models to get an idea what this thing is about. This being a hospital building contains a lot of ducts and pipes and equipment, and you just have to be patient when you do that on a large building. The best practice, of course, is to isolate the components by their Revit category. You don't want to mix them all up together, especially on a large building. That makes it very easy for you to qualify the penetrations and assign the proper material and find fire rating. Okay, so this is the NWC file of Navisworks has been written to the hard disk. I'm going to close down this file and go ahead and open another one. I'll just open the architectural just to show you what it looks like, and then we'll look at the structural and the plumbing, and then we'll export that. Then we go to Navisworks. It's okay to have linked files here. I have the architectural file open right now. You can see the floor slabs and the roof slab right here is actually part of the structural file. If I can grab it. There we go. So I just selected this so you can see that there's actually more than one model overlapping each other here. The architectural is in gray color and the structural is in blue. Very large building, very complex, has a lot of things in it, including those solar panels on the roof. So when you export this to Navisworks, you can choose or not to export the linked file or not. I would recommend do that. Only export the current file. So what's in the architectural file? We have basically the walls. We need to identify those walls that are fire-rated walls. So in the same process that we were able to filter the walls by their category, earlier, we can filter the walls by their category as well. So I'm just going to show you that you may have different types of walls. Some of them are 1 hour rated, some of them are 2 hour rated, so you can also go through that and qualify those as well. In the interest of time, I'm just going to keep going and show you the other models. I will open the plumbing model and then the structural. Okay, so in the plumbing, you got the same thing basically. Let me zoom in here on the plumbing. We have there is the plumbing fixtures, the different pipes, pipe fittings, and pipe accessories, and you want also to go through the process of qualifying those as well. And since I did that already, I'm just going to continue, and I'll show you the structural. With the structural, our main focus would be on any structural walls and structural floor slabs. In this case, let me switch to the main model. Okay, so this is the structural model, and it actually includes the plumbing model in it as well. So if you zoom in here, you can see that we have some pipe penetrations through the slabs. So the qualifying process for floors is very much like qualifying MEP components or walls in that picture file. We simply isolate those categories and then switch to the HILTI Firestop button application and then qualify slabs. Same thing here. We are going to we can sort by fire rating and simply select all slabs and then go over here and then assign them 1 hour, 2 hour, 3 hour, or 4 hour fire rating, and then assign them the barrier type, whether it's concrete floor ceiling, hollow core floor, or wood floor, and ceiling assembly. And then, of course, the last step is to export this to NWC file format in Navisworks. All right, so what happens in Navisworks? Let's switch to Navisworks. In Navisworks, we're going to start assembling those NWC files in Navisworks by using the append command. And I'm going to bring in the structural file first. Here it is. And the next thing I'll bring in would be the plumbing. And again, in the interest of time, we're not going to bring in all the models because this is going to take longer than the time we have in this webinar. So I'll just, this will be good enough for our purposes. Next step is to use the HILTI add-in for Navisworks to start calculating the Firestop clashes. And I'm doing this live, by the way, so this is the real thing. Okay, so it's basically saying, please save your project. So I'm going to go ahead and do that. And I'm going to overwrite the previous model I had before, which is typically I like to add the discipline name at the end of this file, STR for structural, and PLU is for plumbing. And we'll go ahead and save that NWF file. And then start the process of calculating the Firestop clashes. So as you can imagine, for a big hospital, this process can be very elaborate, and it may take longer or shorter time depending on the complexity of the clashes. But it's best practice to isolate the plumbing and structural together, and then run those separately so you can focus on the. So we have here 416 clashes in total, and it looks like it's running pretty fast. So if you work on a large building, you may want to budget maybe half a day for this entire process. If you're just starting to learn the HILTI Button Firestop or Navisworks, you may want to budget maybe a whole day for that. So the good news is that we don't have to go through search sets in Navisworks. The application is able to recognize these different penetrations automatically, and here we have the clash detection already finished. This is great news. Now we can go ahead and save this and switch to the Results tab. In the Results tab, we can simply just switch between different components or clashes, and I can turn off the highlighting of the red slabs like that, so it's not red anymore. This way, this way you can see anywhere where you have a pipe penetrating a floor slab, Navisworks has located this as a red spot, which means that it needs to be investigated by the Firestop manager. So let's switch here to a different clash. Okay, so everywhere where we have a penetration, Navisworks has placed a symbol that indicates where the penetration happens. Next, we will move on to starting the Firestop manager. It will ask me to go ahead and save, and I will do that, and then start the Firestop manager. And it's going to process those penetrations and suggest UL listed solutions for these penetrations. This could be either a HILTI product such as a Firestop collar or a Firestop block, a sealant, or a cast-in place device. Okay, again, don't forget to send your questions to Alyssa. She's waiting for your questions. Okay, so that wasn't too bad. Navisworks launched the Firestop Manager, and we have we sort here by name. The clashes are a total of 416 clashes. So you can have an idea how much time it takes for that many clashes. So if you have 10,000 clashes in your model, you may want to budget for that. Next step would be to assign the Firestop solutions to these clashes. Go ahead and do that. And this would be the best recommended clashes for those. So clash number 1 over here in the list is going to give us a cast-in device, and this is the model number, and that's the preview of what this thing looks like. This is the one the contractor will have to locate on the floor slab on top of the metal deck before they pour the concrete. So very important to locate those accurately. Again, let's go through several of those. I'm going to sort by product, so I'm going to come over here and say, okay, this is a cast-in-place device. Let me scroll down and find some other ones. Here we go. This is class number 404 is basically a sealant, Firestop sealant, and so on and so forth. So there's different types of model, different type of clashes that were recommended here. But what if we don't want the recommended product? What if we want to change that? Can we do that? The answer, of course, is yes. So what I'm going to do here is going to come in for a clash number 1 and then select a different product. I may select, for example, let's see here, a different, different custom-based device, different model, and then I go to clash number 2 and then do the same thing. What's cool about this is that, of course, is that all of these solutions are approved by HILTI, so we don't have to worry about which one is approved, which one is not approved. This is another device that's maybe appropriate for this type of penetration. Here's another one. And then as of clash number 4, what I'm going to do is I'm going to actually do something different. I'm going to choose EJ, which stands for engineering judgment. When I do that, that means that this is flagged for further investigation. And then I'm going to ask Hilti to give me a recommendation of what this thing should be. And I'll do that for several of those so we can see them. So class number 4, 5, and 6 are going to be EJ products. Okay, so this is great. Next is if we wanted to look at the product itself on the Hilti website, we can do that. We can also look at the system cut sheet. So let's take a look at that. So this is when we click on the system cut sheet, it's going to open for us a cut sheet of this device penetration. Look at the product itself. This is live on the Hilti website right now. Let's just look at it. And this is the cast in place device for combustible penetrations. And what else can we do here? We can unassign what we just did, in other words, undo, or we can match certain types of penetrations to other types of penetrations. We can also create a BOM, bill of materials, or quantities. Let's do that. And this related to the quantities, we have 3 engineering judgments. We have one drop-in device, we have cast-in device, and some other seal-in devices. You can also have colors and what have you. And what I'm going to do is I'm simply going to save this in the proper folder here. And we'll just call it number 2 here. And the last step in this process in Navisworks is to create a submittal that we can give to the authorities or the fire marshal. And again, I'll do that as number 2 as well. This will be saved as a PDF file, and it will open up in a moment. Okay, so this is the submittal package. It's 40 pages of all the quantities, submittals, bill of materials, cut sheets, and we can just zoom out here and start, giving this a name. For example, I'm going to call this the Autodesk Hospital. Okay, that should actually be the submittal, and so on and so forth, and then we can save the changes to this. And then, what does this submittal contain, by the way? Let's take a look. So I'm going to go here page by page. It has a table of contents. It's got the cut sheets for the different systems. More information from the Hilti regarding installation procedures and best practices. Certificate of compliance. Other data sheets that you can fill out. And some letters that you can also submit to the fire marshal for lead certification. Another certificate of compliance from the vice president. More certificates. This is for each device, by the way. And here's a list of all the penetrations and all the devices that were recommended as a solution for this. So it's a pretty good document. Let's close this one down. And we're also going to close down the HILTI Firestop Manager. As soon as we do this, you'll notice that these red marks in the Navisworks model are going to change color, and they should turn either green or yellow. Green indicating that a solution was found. Here we go. A solution was found to these Firestop penetrations, and you can see that same color is indicated here as approved, which is perfect for this. Exactly how Navisworks work. Now, if you remember, some of these penetrations were changed. We changed them. So this is, we changed this one from the whatever it was to model 2054, while this one was model 1016. Clash number 4, if you remember, was assigned EJ, or engineering judgment. So in the comments of Navisworks, this is listed here. So what I'm going to do is I'm going to take advantage of that, and I'm going to create a report in Navisworks. I'll make that report show the summary, the clash points, data approved, item ID, distance of clash, etc., etc., and then I will also make that an HTML tabular report, and I'll go ahead and rewrite this report. So I'm adding number 2 at the end because I already have one. What that's going to do is going to create a HTML file of all the clashes with thumbnails of every clash, and then it will basically look. You can open that HTML file in your browser. That file can be also saved as a PDF or MHT, which combines all the images together with the HTML file in one file. So what does this look like? It looks something like this. And here it is. That's the one we just created a moment ago. It is July 21st at, no, not this one, sorry, this one, at 1:12 p.m. Eastern Time. Double click on that HTML file. It will open up and will show you the clashes listed. So you have the blue items and the pink items here. The blue items are basically, it shows here as metal decking. Let's just take this one. This is a concrete 5 KSI element, which is a structural slab on the left. On the right, we have a plastic penetration of a plastic pipe running through that. And this is the HILTI Firestop solution. Okay, this happens to be the EJ one. So what's cool about it, of course, is that the whatever we change under the HILTI judgment will also show up in the comments. So I'm going to scroll down here just a little bit to show you the cast-in device that was recommended by HILTI earlier. We have an element ID, so you can send this information either to the mechanical engineer or the mechanical contractor to locate that copper pipe, in this case, in the BIM authoring tool. So very, very useful information here. Okay, so that's what we do in Navisworks. Of course, we're going to save this in Navisworks and then switch back to Revit. In Revit, we're going to use the insert firestops command to bring in all these penetrations and devices back into the slabs and create these holes in the slabs. Now, due to the amount of time this will take, I'm not actually going to do this live because it may take longer than the time we have. So I'm simply going to just open up the final product. I have here a model saved as final that I prepared for you in advance. So I'm going to go ahead and open this. So what this will allow you to do is will allow you to not just locate and qualify those penetrations, but also populate your model with these penetrations. And I'm zooming in on this, and you can see where these different types of devices are. This is the cast-in device. If we click on this, you can see clearly that in the Revit properties, this is a cast-in device for metallic penetrations. It has the model number, just like any other family. It's basically a specialty item family, specialty equipment Revit category. We have other devices. This one in particular is a Firestop color, and then over here we have the sealant, the Firestop sealant. So very effective way to do the round trip between the BIM authoring tool to Navisworks, Manage, and back into Revit. The last step we do here is simply we can quantify these components in a Revit schedule. So I'm going to take a couple more minutes and then I'll turn it over to Alyssa. I'm going to simply create a schedule, and I'll make that schedule of a specific category called specialty equipment. And what goes in this? We probably want to have we want to know what level it's on. We want to know what family is it, family name, the type name, and we also may want to sort by a certain value. I want to know the count also. So how do we sort? We can sort by something called copyright. The copyright is a way to filter something Okay, so HILTI products have a tag that is assigned as a property of this, and this if it sees the word HILTI, it will show it. If it doesn't, it will not show it. So we don't want to mix those with all the other specialty equipment that exists in the model already. We're going to sort by type and add a footer and a blank line in between, itemize every instance or not, grand totals. And then, of course, we want to count. We want to do the calculate totals for the count. And of course, what that will do, it will generate a quantity for every type of UL listed device. Here are all the cast-in devices, a model of this specific model. These are the 2-inch, these are the 3-inch. Okay, and then different models as well. So in short, and if you don't want to list every single item, we can go back to Revit properties, and you don't have to itemize every instance, of course. That will give you just a summary of what these would look like. Okay, with that, I'd like to turn it over to Alyssa for any questions. Thank you so much.
Thank you, Robbie. That was a great presentation. I do have a few questions here. First one is, will HILTIButton for Firestop run in Navisworks Freedom or Simulate?
Good question. The answer is no. Since the Navisworks Freedom and Simulate do not have clash detection, the HILTIButton for Firestop will only run in Navisworks Manage, which does have clash detection.
Got it. Okay. And at what phase in the project should we run the HILTI app?
Yeah, that's pretty much follows the degree of level of development or detail that you have in the project. So you can run it basically at any phase, as long as you have those components in there. So first, you want to make sure that you have 3D models. Not just 2D drawings, and that the fire-rated walls and floors and are actually fire-rated, and then the MEP components such as ducts and pipes and cable trays exist in the model.
Okay. Can the HILTI Firestop components be quantified in both Revit and Navisworks?
Yes, actually, that's a good question. Let me see if I can switch to that. Yeah, sorry about that. So if you remember, we saved the BOM, Bill of Materials, as a spreadsheet. This is it right here. So, so this is the bill of quantities that came out of Navisworks. And it's basically just a simple spreadsheet of quantities that you can quantify. We also were able to quantify them in the Navisworks report, and we were able to quantify them also in Revit schedules.
Okay, that's excellent. What Revit family category is used by HILTI?
Yeah, I think I mentioned that earlier. We did use the specialty equipment schedules when we scheduled all the components, and so this is the only Revit category that will be used, specialty equipment.
Okay, sort of back to the previous question, do you need to run manage to do this process, or can it be done from Revit or AutoCAD?
Okay, well, the BIM authoring tool is going to be Revit or AutoCAD MEP and Fab MEP. But as far as the clash detection, it has to be done inside of Navisworks Manage.
Okay, excellent. How did Revit populate Revit families from Navisworks?
Okay, so we did start the Firestop Manager, and the Firestop Manager was generating a database in the background. So this Firestop Manager document contains the information that was populated from the HILTI Firestop Manager with all the UL listed devices. And so Revit is not reading the information from Navisworks, it's reading it from the Firestop Manager.
Okay. Can you explain how EJ works?
Yes, EJ basically stands for Engineering Judgment, and the HILTI button for Firestop basically eases the process of applying for engineering judgment by driving the user to the HILTI online website in order to fill out a form and submit it. So this would be more of a special type of request from HILTI where a Firestop solution is not found.
Okay, that makes sense. What about where can we download the HILTI Button for Firestop app?
Okay, so basically you can do that from the HILTI website, or you can just Google it. So the name of the product, of course, is listed here at the bottom of the slide. HILTI Button. HTTPS //HILTIbutton.us.hilti.com.
Okay, excellent. Last question is, can you go back to the clash model and make changes after closing?
Yes. You can change your mind at any time. You're not locked to a decision. So even if you ran the clash and did not find a solution, or you missed to qualify a certain duct or pipe or material or installation, you can always go back and amend what you just did.
Okay, great. Well, that's all we have time for today. In a moment, our Hangout survey will pop up. Please complete the survey to be entered to win a $25 Amazon gift card. You must complete the survey to be entered into the drawing. The survey will take only a couple of seconds to complete. Thanks for hanging out with us today. We hope you found this Hangout informative and helped your business. We look forward to seeing you on our next webinar. Thank you.